clearly not the end of the world. And it's probably not even the end of America. For many countries, this is going to be the beginning of an economic boom, a giant burden being lifted off their shoulders, where the world no longer has to loan trillions of dollars to Americans so that we can continue to consume what we don't produce. When this comes to an end, the world will benefit. So it is not something that we should fear. We should embrace it as a world.
This is the greatest wealth transfer in history. If we have a global currency crisis, then you're going to see a greater wealth transfer than has ever happened in all of history. It's all going to happen at once. Therefore, it's the greatest opportunity.
We have millions of people now taking an interest in what is money, the question of what is money, what should it be? And they're learning, especially a lot of young people.
The sun will rise tomorrow, as it has a million times before. Commuters will wake up and travel to their offices to begin the day's work. Farmers will tend to their crops, and construction workers will build new infrastructure. But will the world they live in still be the same? In 2008, the world was given a wake-up call. The biggest financial crash in human history was delayed by the same poor decisions that brought it about in the first place. What that massive bailout bought us was not a solution, but merely time. Time for the people responsible to wring the last few dollars out of the dying system. But also, for those able to see the cliff edge approaching, time to protect themselves and their families.
Oh, I just got an early excuse.
Sustainable, eco-friendly, recyclable, and green. There are many terms we use, and we're always interested in what the industry has to offer in these areas. This is Lecture, and today we're bringing you 15 of my favorite sustainable houses.
Number 15.
Amsterdam-based Fiction Factory is responsible for this modular house, and I'm seriously bothered by the fact that I can't have one shipped to the U.S. Each 54 square foot section is formed by wrapping 24 layers of high-strength cardboard around a mold. The outside is then covered with a waterproof film and a shell of wooden slats to protect it from the elements. The interior is covered with a formed plywood, which is also used in separating the living spaces. Each piece weighs in at 1,100 pounds, eliminating the need for a foundation once on site. The modularity allows for a flexible building style that lets the owner create their house in any fashion, as there's no limit to the number of sections that can be connected. Current pricing on this one will run you about $34,000 for a 3-section home.
Number 14.
This structure, which is used mostly as a holiday retreat, was designed to be mobile due to zoning laws regarding local beach houses. The owners did this by building it on 2 wooden sleds, which allow it to be moved easily over land. The front wall winches open to form an awning above large glass doors, which swing open to reveal a living room, dining area, and kitchen. Behind the kitchen is the bathroom and the children's sleeping area, which consists of 3 bunk beds. A loft area above the kitchen houses the main bedroom with a wall-mounted ladder that goes from the lower floor to the roof, which also serves as an observation deck. Other than the occasional non-recyclable waste, the structure is self-sustaining, including a worm tank waste system, which you don't see too often.
Number 13.
This project in the Netherlands started with a piece of agricultural land that was transformed by planting 70,000 trees and building an extremely huge pond for migratory birds. The elevated structure has a total floor area measuring 7,700 square feet. The open floor plan and rectangular design allows for almost uninterrupted views from one end to the other. This lack of walls allows the glass enclosed structure to take full advantage of the natural light as well as the heat that it creates. One of the supports for the house also serves as access to the outside, leading to a lower level with another living area and a 6-car garage. Power for the house comes from a roof-mounted solar array measuring just over 3,000 square feet. This, along with the thermal recycling, creates an excess of energy that can be stored for use in cooler months.
Number 12.
The Zero House is a 650 square foot micro dwelling that can be assembled almost anywhere in the world in just one day. Its foundation consists of 4 ground posts, allowing it to be constructed on almost any terrain, including water. The completely off-grid home can accommodate 4 adults in the dual module setup. The lower module contains a full-size kitchen and living room, while the upper module houses 2 bedrooms and the bathroom. This one also utilizes the outdoor space via decks on each side, which sit on the roof of the lower module. The starting price on this one will run you around $350,000.
Number 11.
This home, located on a wooded hilltop above Michigan's Glen Lake, started as a 1-story cabin, which morphed into a 4-story tower with a smaller footprint. All told, it offers 1,400 square feet of space over 3 levels, which sit a full level above the ground on 2 side walls. The structure, for lack of a proper description, is basically a plywood box suspended between metal walls with some glass thrown into the mix. The bottom level houses a mudroom and the guest bedroom, while the level above that has the main bedroom and bathroom. The uppermost floor includes the living room, dining area, and kitchen, as well as having floor-to-ceiling windows that provide an almost uninterrupted view of the surroundings. Each level also has its own separate deck, providing even more space to enjoy the landscape.
Number 10.
This small development, Western Australia, sits on a plot of land which was divided into 4 lots. The building process involved using over 90% recycled construction waste from the previous dwelling, as well as other demolition sites. Like most designs of this nature, each house is set in a way which allows better temperature control through cross ventilation and maximizing solar access. A 2 kilowatt solar array provides for the electrical needs while still creating an excess of energy, which adds to the carbon positive nature of the home. Dual plumbed rainwater tanks flow to the toilets and washing machines, as well as providing water for the landscape. The floor plans are laid out to increase flexibility and adaptability for long-term use, allowing for minimal changes when reconfiguring the internal structure. This approach not only provides a multi-generational home, but also creates a space that can be turned into its own self-contained living area if needed. While you're trying to figure out how to milk your neighbor's solar power like you do their cable service, be sure and hit that subscribe button and click that bell icon to keep up with all of our upcoming videos.
Number 9.
This A-frame prototype is located on an island just outside the Helsinki city center. Nalo, which is Finnish for zero, is named for the cabin's purpose of getting visitors to live using lead.
Hello, Rika? Hello?
Hello.
You remember how the class on Wednesday was going to be short because of lab time? And how we have Zoom class because we don't have to go? And
Do you know how to shape the camera?
no, how do I change my name with that? It has a weird way of logging in. Can you help me?
Yes, you can open the camera and
Okay. Also, I already found out like 10 minutes ago. I was kind of hoping you'd take about 2 more minutes.
sorry.
It's all right. I love you. I'm so hard right now, mommy.
So don't change your name again.
So I should keep it as Rika's bitch.
No, I don't want to see your name. So bye-bye. It's time. Bam.
Mommy,
Yeah.
I need you so bad.
I need you so bad too. But now it's night.
Mm-hmm. But there's a problem, Rika.
You have to
Rika, can you do me one favor? Look at your pictures.
love you so much.
Please, I need you. Please teach me Rika.
Who said that? So weird. Okay. There he is. We were worried about you. Good grief.
Me?
No, not you. Lewis. We worried about you yesterday, Will.
Okay, I got you.
Yeah. Black sheep. Whatever. So, Wilson. In order to put your uglies books, please open your textbooks to page. I have no idea, but we're gonna find it. Page conduit bending. Page 160. In order to understand how to bend conduit in a way that does not look foobarred, we must know some math, some trigonometry, trigonometry. 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 Most importantly, we need to understand triangles and how to find angles and sides using trig. So, y'all remember something called SOHCAHTOA? Oh, yeah. Can I get a yeah? Thank you.
Aw.
What?
Oh, yeah.
Mom? Okay, what are we doing? Trigonometry. SOHCAHTOA. And maybe you've never seen this before, but for those of you that have, what does SOHCAHTOA mean? It's a brand of pants. Very nice denim pants. It does kind of sound Hawaiian, doesn't it? Nobody knows what Sokotoa means? Yep. Yeah. Oh, yeah. That doesn't help. Your Ugly's book teaches you, oh, hell, another hour of Andy. And we're not getting into cotangent, secant, and cosequent. Secant. We just care about sine, cosine, and tangent. So means sine of the angle equals opposite over hypotenuse. Cosine of the angle equals adjacent over hypotenuse. Tangent of the angle equals opposite over adjacent. So these are the rules that we use to solve for triangles. So Katoa means sine equals the opposite over hypotenuse. Cosine equals adjacent over hypotenuse. And Toa, tangent, equals the opposite over adjacent. So how do we use this to solve a triangle? Well, let's just look right into it. I'm going to draw a triangle that looks a lot like the one in your Uglies book, but let's say we knew that this distance x was 5 inches. This looks like it's about y equals 1.5 inches. Let's not do that yet. Let's say we want to solve for y. And this looks like it's about a 20-degree angle. 20 degrees. So the first thing we need to understand is what the hell a hypotenuse is. These are all right triangles that we're dealing with. Do you know what a right triangle means? It means that one of the angles of the triangle is going to be 90 degrees no matter what. So that's 90 degrees per time. So what is the hypotenuse in every single right triangle?
Side that's opposite of the right angle.
Yeah, opposite of the right angle. So you go opposite of where the right angle is. This is the hypotenuse. In this triangle, which one is the hypotenuse? B. In this triangle, Q, X, and which one's the hypotenuse?
Z.
Z. You always got to know where the hypotenuse is. So relative to any angle in a in a right triangle, you're going to have a hypotenuse, you're going to have an adjacent, and you're going to have an opposite. So what does the word adjacent mean? Adjacent. It means next to. So in this top triangle, which side is adjacent to the 20-degree angle? X. Why not H? It is always the hypotenuse. And then which one, if this is adjacent, which one's opposite? Right, this is opposite. And this ABC triangle, which side is adjacent to this angle? A is adjacent to this angle. So that makes which one opposite? C is opposite. And this QXZ triangle, which one is opposite of this angle? X. Why not Z? Because it's the hypotenuse. Which one's adjacent to the red angle? Q, next to. Everybody got your head wrapped around that? Okie dokie. If you don't chime in, I'm going to assume that you understand. So we will move on. I guess I can leave that there. All right. This 20-degree triangle, we know that this X is 5 inches. Can we solve for Y using the trig functions? Yeah, I think so. Yeah, yep. If you get 2 variables, you can solve for a third, and it doesn't matter which one. You could solve for the hypotenuse. You could solve for Y in this case is which one, adjacent or opposite? Y, is it adjacent or opposite of 20? Opposite. So rule number 1, or when we're solving for these, rule number 1, find the function. Which function? Which function are we going to use? In other words, are we going to use sine, cosine, or tangent? Which func? Which func? So relative to this angle, what are we given? We're given adjacent. We're trying to find the opposite, correct? We're not even looking at the hypotenuse, but we have an A and we have an O. So which function are we going to use up here? Sine, cosine, or tangent? We have an O and an A. Why? And we're looking for opposite. Does this have an opposite in it? Nope, not that one. We have an adjacent. We're looking for an opposite. So which function? You got 3 choices. Which one has an O and an A in it?
The third one.
The third one.
TOA.
What is that called? T.
Tangent.
Tangent. We know we're going to use tangent. Step 1, done. Step 2, write the frickin' formula. Tangent of the angle equals, and I'm writing this one up here, opposite over adjacent. Step 3, plug and chug. Plug and frickin' chug. Tangent of 20 degrees equals opposite. We're not given that one. We have to find it over adjacent, which we're given 5 inches. So on a calculator, And keep in mind, you can't use your phone for a calculator, so you better either bring one or figure out how to use this one that's on the computer. And I will show you how to use this one on the computer. Pull this little doodad up and go, hey, I want you to go bigger. No, I want you to go scientific. And it looks like this. Anyway, so if we solve for this algebraically, we get 5. And let me know if you need me to walk you through this algebra, but I'm assuming you know it. 5 times the tangent of 20 equals opposite. Can everybody get from here to here algebraically? Thumbs up means go. So on this one, what you're going to do, anytime you hit, and it's the same with your, if you get a scientific calculator from the bookstore, it's the same type of deal. But anytime you hit tangent or cosine or sine, if I hit this button, tan, click on it, it's going to take the tangent of that number. So I'm going to clear it out. Get out of here. How do I do that? Get the back. C. Yeah, that one. Okay, 20. Tan. And it gives you the tangent of 20. You see that? On your scientific calculator, if you do it the same way, if you hit the button tangent, it's going to take the tangent of whatever is on the screen right there. So I get this one, I get 0.363, that's the tangent of 20. Go times 5 equals 1.82 inches. So O equals 1.82 inches. And it makes sense. The last thing you want to do is look at this triangle and say that makes sense because that's about a 20-degree angle. This, if you folded this down, it looks like it's about a little less than 2 inches. If this is 5, this would be a little less than 2, right? So it makes sense. O is 1.82 inches. Got it? Okay, you remember the steps? You guys are all taking good notes. I'm sure you got them written down. Let's do another one. We're given 80 degrees. No. 72 degrees. And this is 9 miles. And we want to figure out what this is. We'll call this X. Step 1. What is it? Which funk? Walk me through that. Yep. So finding the function means relative to this angle. What are you given? You're given an opposite and you're given the hypotenuse. Correct? If we're given an opposite and a hypotenuse, we know we're using sine. Sine funk. Step 2, what is step 2? Remember? I said it with authority. Write the frickin' formula. We already found the func. We need to write the frickin' formula. What is the formula for sine?
Opposite over hypotenuse.
Sine of the angle equals opposite over hypotenuse. Step 3, plug and frickin' chug. Sine of the angle is 72 equals opposite is 9 over h. Solve for h algebraically, and we get h equals 9 divided by the sine of 72. Can everybody get from here to here algebraically, or do you need me to walk you through it? Okay. So what do we get for h then? Makes sense because it's a little bit bigger than 9, right?
10.46.
Yep. 9 divided by, and then I put the number in there, 72, and then click sine, and then equals 9.46 miles. Does that make sense? It does to me. Because if you take this hypotenuse and you swing it over in line with this, it's going to be a little bit longer than 9, correct? Ba-doop. About 9.46 to be exact. If you punch this into your calculator and you get 47.39, you're going to go, hey, whoa, something's wrong there. Or you did something wrong on your calculator. Maybe you hit sine and then 72 instead of 72 and then sine. But I'll do examples all day long if you guys want to. If you're good, you're good. We do need to do a different example. Everybody got this written down? Let's do another. Somebody tell me when to stop. Say stop.
Stop.
Okay. We need to do a couple more examples. Why won't you change? Okay. 43 degrees and we want to find this one, and this is 12.2 meters. Walk me through it. Step 1. Which func? Sine, why? Relative to the angle, what are we given? We're given an adjacent and a hypotenuse. So does that mean we're using sine or cosine? Yes, sir. Cosine. Step 2. What is step 2? Write the formula. Cosine of the angle equals adjacent over hypotenuse. Step 3, plug and chug. Cosine of 43 equals x over 12.2. Solve for x and you get x equals 12.2 times the cosine of 43. So I'm going to go 43 cosine times 12.2 equals, and I get 8.92. And the unit is meters. I don't think there's a homework assignment or a quiz or a final exam trig question that makes you put the units in there. Just rule of thumb is going to be round your answer to 2 decimals. Capiche? Does this make sense? Does this look like it's about 8.92 meters? I'd say so too. Because if you hinge this down, you know that this distance is 12.2. That looks like it's about 8.9. Looks about right. All right, so we just did 3 examples, one with each of the trig functions using an angle and a side to find the other side. But you can also use these to find the angle given 2 of the sides. So that's what we're going to do next. But these rules, the steps themselves, are still the same. Bloop. Okay, so let's say we know that this is 56 inches. And we know that this is, I don't know, 42.5 inches. And I want to know what this angle is. And I'm going to call it, I don't know, beta. The angle beta. Now we're getting Greek. It's getting serious. Step 1. Same steps apply. Step 1. What is it? Yep. Step 1 is find the funk. So relative to the angle, we're given an opposite and we're given the hypotenuse. Opposite, hypotenuse. So step 1 means our function is going to be sine. Step 2, write the frickin' formula down. Sine of the angle equals opposite over hypotenuse. Step 3, plug and chug. Sine of beta equals 42.5 divided by 56. Now here's where it gets a little tricky, because how do we solve for this angle? We want to algebraically solve for beta. So we need to move this sine part over to here somehow. Algebraically, you divide it by sine, right? That cancels, and you're left with beta on the left. But this side, if you divide it by sine, what does that look like? Do you recall from any of your math classes that if x is on the left, the inverse of that would be 1 over x? This is called the inverse. In other words, if we take something divided by sine, wouldn't it be saying it's the inverse sine of that thing? I would say so. So if we take sine and we make it 1 over sine, it's also the inverse, correct? That also looks like this on your calculator. Sine to the -1 power. Anything to the -1 power means 1 over that thing. So back to where we were, we have this formula. Beta equals 42.5 divided by 56 divided by sine. That's also the same way as saying beta equals the inverse sine of 42.5 divided by 56. So on your calculator, what that looks like is, where's the inverse sign on here? There it is, inverse. Okay. So on your scientific calculator, you've probably got a button that looks like this. Do you or don't you? Do you, Lewis? You've got one in front of you. Can I see your calculator, Lewis? So I can I see it for a second so I can demonstrate? So this is the one that you would get at the bookstore. And inverse sine is right here above sine. So in order to solve for this, what we got to do is go, let's see, 42.5 divided by 56 equals, and then we got to hit second. So this is the decimal of 42.5 divided by 56. To take the inverse sine, I go second, sine, and you're done. 49.37 degrees, because we're finding the angle. So this would be 49.37 degrees. On this calculator, to solve that, I'll go 42.5 divided by 56 equals, and then click inverse. And it says sine minus 1. Bloop. There it is. 49.37 degrees. How are we doing so far? You're probably saying to yourself, hey, Zach, what's this got to do with conduit bending? You're on a need to know frickin' basis right now. And I will tell you next week why we need to know this. Just kidding. In reality, if you want to know why we need to know about triangles, look at your uglies book. On the next page, this is a conduit. if we got to get that conduit up and over something to get wire to something, we need to know how to work these triangles. Okay, that's why we're doing this. And I will work all of that into practical knowledge next week. But for now, I just want to get the math locked in. Okay. Somebody give me a number between 1 and 100. What? 64. Somebody give me another number. Okay, 50. Thank you. Millimeters? Yep. These are millimeters. So we're given that, and I want to know what this angle is. Use beta again. Walk me through it.
So use a adjacent and an opposite. So
Yes, sir. That's what I'm saying. This is the hypotenuse no matter what, right? So relative to this angle, we've got an opposite and we've got an adjacent, which means we're going to use tangent. Step 2. Write what down? What is it?
is tangent of the angle equals opposite over.
Perfect. Keep going. Step 3. So what does that look like when we plug and chug?
So it's the tangent of whatever the name of the angle is equals 50 over 64.
Would that be opposite over
Oh, yeah, no,
adjacent?
64 over 50.
I'm glad you said that because that mistake happens a lot. Make sure you plug the right chug into the right chug-a-lug. See what I'm saying? So algebraically, when we solve for that, what does it look like?
Tangent.
Nope.
Inverse tangent.
Yeah, but what? Yeah. So it would be beta equals inverse tangent of 64 divided by 50. In order to solve this algebraically, right next to number 3, you would divide both sides by tangent, right? To get b by itself on one side of the equation. When you divide something by tangent, it's the same as saying times the inverse tangent or times 1 over tangent, which is why we can skip that, all of that nonsense and just say, well, beta equals the inverse tangent of 64 divided by 50. Punch that in the old calculator and we get 64 divided by 50 equals inverse tan 52.00 ohms. I want to find this angle now. And I'm going to tell you that this is 2.26 millimeters. And I'm going to tell you that this is 3.41 millimeters. You get this one right, then I'll stop doing examples unless you want to keep going. Will,
Yes.
sending to your sheep?
No, I'm not.
Can you walk me through this one?
Okay.
Step one.
Step one, we need to decide if it's SOHCAHTOA, what part of SOHCAHTOA it would be. So
Find
we
the funk.
have what part of funk. So we got the adjacent over the hypotenuse.
Correct. Relative to the angle, we're given an adjacent, and we're given a hypotenuse. So we know we're using cosine.
Mm-hmm.
Next.
So we would divide 2.26 by 3.14.
You're jumping the gun a little bit. Remember what step 2 is?
Oh. I don't know why I'm blanking.
Write the frickin' formula, remember?
Formula. Sorry about that.
Don't be sorry. What's the formula?
So it'd be 3.14 divided by 2.26.
You're plugging and chugging. That's step 3. What's the formula?
Adjacent over hypotenuse. Divided by cosine. I meant times cosine.
Adjacent over hypotenuse times cosine. Does that look like the formula that's in your uglies book?
I do not have my uglies book with me right now.
Well, there's one on the screen.
Sine.
If you write that down and plug it and chug into that, you're going to get it wrong.
Okay.
Cosine of the angle.
Cosine.
Cosine of the angle equals.
Cosine equals adjacent side over hypotenuse.
Yes, sir. Now we can plug and chug. So what does plug and chug look like?
2.26 divided by 3.14
Gigawatts.
2.26 divided by 3.14. Then you do was it the cosine tangent or negative cosine? Sorry about that. And you get the angle of 43.96 degrees.
.26 divided by 3.41 inverse cosine. 48.49 degrees. Is that what you got?
Yes, it was.
Yeah.
Negative.
Okay, thank you. All right. So we did 3 examples of each. Each meaning in the first 3 examples, we had an angle and a side, and we solved for another side. In the second 3 examples, we had 2 sides and we solved for the angle. So there's basically 2 types of situations you might see on the homework and the quiz. Right? And you're comfortable with these steps being able to get you to where you need to go on every question, right? Okie dokie. Well, let's look at what we got. You got trig homework. And let's, whoops. Make that due Monday. Multiple attempts. My ass. We'll make that due, today's the 1st, so let's make that due Monday. It's Friday's a lab day. And we'll go over it on Monday. And if everybody's groovy with it, then we'll take
You're
a
talking
quiz.
about next Monday. That's Labor Day.
Yeah, we're not going to be here Monday, are we? So we need to make that due Wednesday the 8th. Thanks, Garrett.
Yep.
All right. I would encourage you to do this on your own to make sure you understand it. I'm not a babysitter. I'm not the homework police. So you have every ability to do it the wrong way. There's right and there's wrong in life. You know what I'm saying? The wrong thing would be to sit next to your buddy and go, hey, what'd you get for number 1? Do it yourself. Make sure you understand it, because when you get to the quiz, you're not going to be able to do that. So anyway, that is that. And we'll cut loose to the labs unless anybody's got any questions. Anyone? Going once?
Yeah, I got a question for the algebra stuff. I was asking. I'll just go through the show.
Okay. Who put something in the chat box? 8.55 miles. Was that right?
No, I was pranking you guys.
Oh, you jerk. All right. See you later, Zoom people.
See you.